Okay, now to go on, I do say lastly up here, but there's some bits more after this. This is the form of the equation. Most of the equations that we came up with had a similar form to this. Okay, sometimes there was an exponential in there. Okay, and the phase might not be written as phi, but just as an example, this equation can be written like this. It's a sinusoid, that equation. Okay, with a certain starting point talked about by phi. Okay, and this equation, this one down here, can also be a sinusoid. Okay. Now we've obviously got a cosine and a sine in here, but obviously you can still have that being called a sinusoid. And to get from one to the other, it's quite straightforward. If you know the trigonometric sum and difference identities, we know that if you've got cosine of u plus v, you end up with cosine of u, cosine of v, minus sine of u, sine of v. Okay, and likewise, vice versa, if you've got a minus in that quantity there. Okay, and you end up with a plus over here. And so we had cosine of omega t plus phi. Okay, so you can plug in that equation. So I've taken this equation here, and I've used this equation here, and this result over here. You end up with a cosine omega t cosine of phi minus sine omega t sine of phi. And what we do is we define a1 to be a cosine of phi, and a2 to be minus a sine of phi. And so you can plug that into this equation, plug these two things into this equation, and you end up getting a cosine of omega t plus phi is equal to a1 cosine of omega t plus a2 sine of omega t. So that's an alternative form for that equation. This here is an alternative form for this equation here. Okay. So you may see solutions written like this, or you may see solutions written like this. And in the next chapter, we're going to be using this as our solution, not that. Okay. But they're the same thing, knowing that you've got A1 and A2 are defined like this. And so, the solution for the free undamped response, okay, so this is the basic form, can be written like this, where A1 is A cosine of phi and A2 is minus A sine of phi. Similarly, for the damped response, we had this form of equation, okay. So now we've got the exponential in here, the decaying exponential. In terms of zeta, we can write that as A1 cosine of omega dt plus A2 sine of omega dt multiplied by that decaying exponential, because that decaying exponential affects the sinusoid. Okay, as time increases, that will reduce the amplitude and it affects the amplitude of the sinusoid. And obviously, for that equation to work, A1 must be A cosine of alpha, and A2 must be minus A sine of alpha.